All right, hi guys. This is Mr. Martis, and it is, Wednesday night around 6 o'clock. This is the video that'll be posted for you all on Thursday. This is a good time to introduce a few topics that really don't fit nicely anywhere else. They are in chapter three, which was everything else we did this week has been chapter three in the book that I said that y'all don't need. I've been picking out the things that I think you'll need to know to be successful and to move on in computer science. So this is the random number generator. This is like really important for a lot of programs. You're going to, if you want to make, especially games of chance, is the first thing that comes to mind that this is good for. But there's going to be a lot of things that you all can use random numbers for. All right, to do the random, this whole program is made just to demonstrate how to get those random numbers and how to pare it down to something that's a little more useful for you to use. All right, you need IOStream, obviously. Then you need, actually, for this, you need two different libraries. C Standard Library, which is probably one of the oldest libraries, header files that I know of. You'll need it for, like it says right here, rand and srand. That's the two functions that or C Standard Library provides. And you're also going to need to include the C time because you need a time function to actually seed this random number generator. And you'll also need the old trusty using namespace. All right, to get started on this, first we're going to get the system time. All right, your system has an internal clock. So what it's going to do is call this function, this time function, with the parameter a 0. All right, it's going to give you a number. It's not it in itself isn't a random number because the number that this time 0 is going to give you is the seconds that has elapsed since January 1st, 1970. Think about that. So it's like 51 years of seconds. All right, it's going to take this number and it's going to assign it to unsigned seed. Unsigned means positive. And obviously, if you're talking about number of seconds, it's going to be a positive number of seconds. All right. So again, time 0 calls upon the seconds since 1970 and assigns it to a variable called seed. And in the program I wrote, I actually made it visible. See out the seconds since January 1st, 1970. Then I've seed out seed. All right. That number is always going to be changing. All right. The reason we're using this, you can put any number you want inside of this number generator. srand is a random number generator. You can put 12 in there and it's going to output something. But what you want to be a really random number is to always be an ever-changing number that you seed it with. This clock function allows you to do that. You're always putting in a different number. It gets bigger and bigger and bigger, but it's going to be different every time that you put it in srand, which is, like I said, the random number generator. Then after you've put the seed inside of the random number generator, then every time you run rand parentheses open and closed, all right, basically you run the rand function, every time you're going to get a different number. Let me run this for you so you can see. All right, just in case you were curious, the number of seconds that has elapsed since January 1st, 1970 is, let's see what this is. There's thousands, there's millions. There's been 163 billion. Am I reading that right? Nope. 1,631,138,513 seconds. So this number, all right, goes inside of the random number generator. And like I said, it changes all the time. And now you're going to print out some numbers. Okay, you put it rand. If you run the rand function, you get 9,837. You run it again just a millisecond later, and you get 17,547. You run it just a second later, you get 28,401. You just keep getting different numbers because it is a random number generator. All right. You're probably thinking, okay, I can't use numbers that big. Really, what did I gain out of that? So here we're going to use something that we learned probably back in week 1. It's the mod operator. So what I'm going to do is I'm going to call on that random number. All right. I'm going to get a random number right here. And then I'm going to go mod 10. Think about what that does. It's going to divide this number by 10, right? And whatever the leftover is remaining, and the remaining is going to be 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? It's going to assign it to num, and I'm going to print it out. So let's watch this. I'm going to do this 2 or 3 times to show you. There's a random number being generated here. You mod 10 it, and you're going to get a number between 0 and 9. 0. Run it again. 3. Run it a third time. Get 6. Run it a fourth time. I get another 6. Get an 8. So you can see it is truly a random number. So this brings into play 2 things: the random generator and the mod sign that we learned back in probably the first week. Right? Remember, mod means remainder. So if you divide by 10, you're always going to have a remainder of 0 through 9. All right. Take some notes on this. Guys, this wouldn't be that hard for you to type in your computer and play with it just a little bit. You can see that this would have a lot of value for card games, all right? Especially dice games. You can make a couple of dice. I could have made 2 dice, made it rand 6, then made your answer, whatever your answer is, make it mod 6. Then your answer is always going to be between 0 and 5. Add 1 to it. Your dice roll is always going to be 1 through 6. So that will be coming up in a game. We do games of chance in this class too. You'll use this mod operator and a 6 and a little bit of tweak of the formula, and it can give you dice. All right, going to take a second to go over another concept with you. All right, I've touched on this before. We did one, and I just went over it briefly. It's actually how to use the exponent function. So for this one, all right, this program asks for the lengths of 2 sides of a right triangle, and it'll give you the hypotenuse. So we're going to be using a squared plus b squared equals c squared. All right, you got to include IOStream, you got to include IOmanip, and you got to include CMath. All right, my dogs are going crazy, so I'm running to another room real quick. All right, just a slight bit of technical difficulty. So we need IOmanip for the set precision. And we need CMath. That header file has the square root and the power functions. We need both of them to figure out the hypotenuse. All right, I'm going to declare a double A, B, and C. As a rule of thumb, you never want to use one-letter variables. That's bad on so many levels. It's bad etiquette, but I think it's a little bit easier for you to see this because A squared plus B squared equals C squared. So the math kind of makes sense. All right, here's what we've got in this program. You've got enter the length of side A, and it's a double, so you can make it any kind of decimal that you want. Enter the length of side B. All right, so you got your two sides. Now let's see how this works. All right, I'm going to separate this for now so you can just look at this. All right, this just means the power function means the first, inside the power on the outside and inside the parentheses, you've got A and 2.0. Just like you'd probably think, that means A squared. All right, whatever the second number is the exponent. Okay, you want to add that to power, which is B squared. The 2.0 means the square. All right, now I'm going to put this back together. So remember, this was, think of it like this. This side over here was C squared equals A squared plus A squared plus B squared. Then to get C by itself, and I know all of you know the math on this, I squared C, then I squared the A squared plus B squared, and that will give me the C that I'm looking for. See out the length of the hypotenuse is, set precision 2, and then I'm going to see out C. Inner length of side A. First, I'm going to do this with something we know the answer to. I'm going to make side A 3 and hit enter. Then I'm going to make side B 4 and I'm going to hit enter. And as you all can guess, this is a perfect 3, 4, 5 triangle. So the hypotenuse is 5. Let me go back and run that again with something a little more interesting. All right. I can make this 12.37 side A, and then I go back and make side B. Let's call it 16.74. Hit enter, and then the length of the hypotenuse is 21. All right. So basically, you need to, out of this, you need to know that there is a square root function. All right. Basically, it'll take the square root of anything inside the parentheses. And you also need to know how to use the power function. Remember, it's power. Then in parentheses, you've got the first one, which is your base, and the second number, which is your exponent. All right, give these a good look because it's like a guaranteed all the concepts that we talked about in this video, the square root, the power function, and definitely the random function is going to be used in future programs. We're going to be looking at making some games of chance, so you definitely need to understand the rand function, and I feel pretty confident that the rand function will be coming up within the next 3 weeks. All right, guys, I will see you all on Friday. Have a good production day.